In this episode, I get to talk with Richard Celine of Roar Partners in Future Proofing America about how we rethink the way we prepare for disasters and build more resilient communities. Richard has spent more than 40 years working at the intersection of government, industry, investment, and community development, with a focus on moving from reacting to the disasters toward preparing for them before they happen. We explore what that shift could mean for infrastructure, building codes, funding, and ultimately the role structural engineers can play in creating communities that are better prepared for the future. Let's see what we have to learn.
The Structural Engineering Podcast.
Max, first off, thank you for what you're doing. I think, any time that we can provide insight and additional information to anybody, including in the engineering space, is always going to be critical. And we'll talk about what we call this pivot that's underway. I'm Richard Celine. I have kind of wear two hats, although it may not look like I have a hat on, but I manage two different organizations that are uniquely tied. One is a nonprofit called Future Proofing America. It's a 501c3, but it is not a charity, although there are certain things that we do that are under nonprofit work. But Future Proofing America is really a collaboration amongst a unique set of experts, from Gensler, the largest global design architecture firm, all the way over to advice and consultation that we've gotten from Moody's and Fitch Ratings, two of the three major ratings agencies, which we'll talk about in this conversation, and the impact for engineering. And Future Proofing America has really operated like a think tank. We brought a whole set of folks. I had to go back and look at this over the past 4 years. We brought over 2,000 individuals with different expertise from different stakeholders, some in person, a lot virtually, to really tackle some of the issues that we'll talk about, but not from, this kind of navel gazer kind of thing, but we're really focused on how do we solve some of the most critical challenges to helping the country make this pivot from being reactive versus being better prepared, or what we call pre-disaster risk mitigation. So Future Proofing America, 501c3 think tank, and Roar, R-O-A-R, Roar Partners, is the for-profit that in a sense commercializes the output from the think tank into the market. And we'll talk a little bit about that as well. So both of those are overseen by an advisory board that is led by the former CEO of Munich Reinsurance, which is the largest global reinsurer. And he was the USA North America CEO. And then we have a board that, in a sense, represents, different aspects, including engineering and design and real estate, mortgage, a whole set of stakeholders. That's what we do, and I'm sure we'll get into it. My background is 40 plus years being in and out of public, private, academic, philanthropic sectors. I've, worked at President Bush 41's White House, ran a couple of commissions and department, agencies. I have a government English degree from the University of Texas, reason why I'm wearing my burnt orange. Mm-hmm. I have a government English degree, which qualifies me to be a dog catcher in any small town in America. So, anything that we talk about, I'll put that caveat that it's been, the blessing of getting a lot of insight from a lot of folks. So, Max, Thank you for the opportunity to visit.
Yeah, well, thank you so much for joining. I'm really, really interested in learning more about this. As I sort of zoom in, we're heading towards the structural side of future proofing, but can you talk a little bit about the current approach to disaster risk from the national level? Is this specific to hurricanes, or is it the bigger picture of what do we do in the face of a disaster?
So what really sparked all of this was, I'm a fourth generation Houstonian. We were not living in Houston at the time when Hurricane Harvey hit Houston, coming up on, maybe 8 years ago now. It's kind of sad the more I think about it. When you get 48 inches of rain in less than, 14, 16 hours, that's biblical rain, right?
Yeah.
And so we were, oddly enough, in Houston a couple of days before, and then got out, came back to Houston, and pretty devastated. And what became, very noticeable, to say the least, was that over about a 50-year period, Houston had a chance, Max, to restructure itself, including a plan that became pretty famous after Harvey that had Houston with a number of canals and different ways to convey water. Okay.
Really?
A little bit like New Orleans, a lot like
Venice?
European and right, right,
Yeah.
right. No one adopted it. We have channels, we have bayous and all that type of stuff. So what really sparked all of this was the reality also in conversations, and I can talk about a lot of this now publicly, with the Army Corps of Engineers, because some of your listeners may recall, Army Corps of Engineers operates two major dams on the west side of Houston, Max, all right? And they refuse to take advice from a number of retired engineers
Yeah.
who didn't have anything, didn't have a cell or, revenue, really wanted to do the right thing. And what they were saying to the Army Corps is every time a major rainfall got and raised the dam levels up to the very lip, all right, or even caused some of it to overflow, was really, really a missed opportunity to release water ahead of an event on a blue sky dry day and let some of that water gently move down the system, the channels and the bayous and all, right? Instead, the Army Corps of Engineers opened up those two dams, I don't know, 36, 48, 72 hours, whatever it was, after Hurricane Harvey, and flooded out another 130,000 homes that had not been flooded by the original storm.
Yeah.
Bingo, right? So I started asking some stupid questions like, what can we do ahead of an event? How do we do it? And what's the economic value proposition for doing more work ahead? Okay. And that led to a discovery of a report that Wharton School of Business up at University of Pennsylvania had done that said, and we'll talk about some of this a little bit deeper, that is, for every dollar you spend ahead of an event, you're actually generating a 1 to 6 cost benefit.
Whoa.
And the Army Corps of Engineers for a long time has operated, they're changing this, has operated under a 1-to-1 cost benefit. I spend $1, I get $1. Okay. I had to be very honest. Who cares? 1-to-1, I really haven't really changed the dynamics against all the amount of the conditions that we have around the country.
Yeah.
So when we talk about resilience and future proofing, it really, Max, is built on the premise that if I do more work ahead, upgrade, retrofit, or even, better construction, then we can empirically, we have the data now, others do as well, but we've got, data that empirically shows that if you spend this amount of money, do these kinds of things, you will get this reduction in risk exposure. And remember, engineering is a part of the risk model.
Gosh.
Does that make sense?
It does. Yeah.
Okay.
And in the just sort of from the definition side, when we use the word resilience, is this surviving a catastrophic event or is this being repairable, operational?
So good question, because sad but true, what we also, found is that the way, and we'll get into some deeper dive on the pivot that we think has been needed and that's somewhat underway, but a lot of communities only get enough money or spend enough money to survive to the next event.
Yeah.
We're focused on thriving in a whole general sense of what thriving means. All right. So our definition of resilience goes back to that definition of pre-disaster risk mitigation. You spend it up front, you benefit from reducing loss of life, loss of operations, loss of infrastructure, whatever the losses are that, mount. Okay. And so resilience is being resilient before, during, and after an event. But our belief is we focus a lot already on after event. We spend a lot of time doing rebuilding. Okay. Yes, we do a lot of recovery for sure, first responders and all, that do that work. The real question is what is the measurable way to get people incentivized to actually prepare for something that, well, Richard, it may not happen. Why should I spend the money? And my question is, are you just completely numb to realizing what happened 3 years ago, last year, you know, 7 years ago? So again, our focus on resilience, Max, is think about the before, during, and after, but with a lot of emphasis on the before.
Yeah, that makes a lot of sense.
Mm.
I can imagine it's very difficult to, you're not forcing people to make these decisions early. There's an economic burden of this, but
Right.
how to encourage this to the point that it is the clear choice for someone.
So it used to be, well, you know what? I'm going to build it to what I only have to build it to based on the code or the rules or the regs. I'm only going to build it to that standard. And then, what I'll do is I'll transfer the risk to somebody else. That's what insurance
Yeah.
is. I'm paying
Absolutely.
Max, I'm doing what I got to do. And then Max, I'm going to write you a big check and you cover all the losses. Well, Max, you go ask anybody in the United States, are your insurance bills going up? Oh, hell yeah. Okay. Now what's beginning to happen is it's beginning to happen on the commercial sector side too, right? You talk to elected and appointed officials, federal, state, county, city, they're tired of going back to their taxpayers, having to get new bonds and raise money to rebuild something, right?
Yeah.
So the pivot that we're seeing has been underway and is now, we believe, really caught up to where we thought it would be. We started looking at this 5 years ago, Max, but where the country is right now, you cannot afford to put this off anymore. And you may think you can, but let me tell you, you're gonna get it in the pocketbook or, the election or whatever. And that is the combination of why we felt Future Proofing America, our framework, we'll talk about that in a little bit, and why Roar's bringing all of this expertise and aggregating markets together is we've been thinking that this was going to happen. It's now happening.
Yeah.
Flood, flash flood, high winds, hurricanes, hail, earthquake, little bit on earthquake. We're trying to establish more things. So it's kind of, the big 5 or 6.
Mm-hmm.
And the other part to it, Max, is we now know the 12% of the United States land mass that persistently gets hit with disasters, one behind each other.
Huh.
And it doesn't mean the other 88 doesn't make a difference. It does. We're just saying to 12%, and by the way, it's not just the coast of the United States, it's inland, because if you include wildfire, you include inland flooding, flash floods like what we're seeing, Max, that's what's happening.
Gosh, I'm thinking about where do current codes fall short, but I mean, in the big picture, everywhere, right? The code is the minimum, like you were just saying, it was built to the code and good, and I could sell this now and it's insurable. But give me in your thoughts, where the current code is really falling short and what changes we might see in the next short term, 10 years.
There are some new ones being introduced for sure. All right. They're there. Okay. It's how they are applied, interpreted, monitored and all. Okay. For the fun of it, Max, we pulled down and found 2,600 building codes, rules, regs, and standards across the country. It's not just LEED. It's not just ASTM. It's not just ISO. There's 2,600 of them. All right.
Yeah.
What we started hearing from insurance and reinsurance, elected appointed officials was, oh my God. Okay. What? And what we said was, let's just harmonize. Let's normalize all of these. All right. So we created what we call a Future Proofing America standard of practice. It's not a new rule. It's not a new reg. It is our way of taking all 2,600 of these and normalizing them. And you know what you find out, Max? 18 to 20 some odd similar things to every rule, every code. Okay. You need to raise it this way. You need to build it that way. I mean, it's kind of, frankly, in no disrespect, because I'm not an engineer. My father was a mechanical engineer. I am not. But we know that there's standards, rules, and regs out there. Okay. Most of the rules and regs are ones that are enforceable, right? Your colleagues in the engineering world incorporate all of those in some way into their work. No question. No engineer is going to put that stamp on anything unless they have hit that level.
Yep.
But the problem is that the level, the frequency, the intensity of all of these events is happening faster now. So the codes need to be looked at in a way that are tweaked, okay, to address this persistency, all right, higher wind, different load factors and all that, all right. But I'm also going to go back to something that you said. There's all kinds of building codes, Max, all kinds of rules, all right. That's a regulatory regulated setting. We believe that there needs to be a corresponding incentive.
Yeah.
Right. And this is where, I don't mean to jump too far ahead, but, where the mismatch between what we have today and the future proofing, the pre-disaster, the resilience perspective is that often rules and regs, building codes, go this way. They go down these silos. They don't go this way. So if I am a structural engineer, most of the folks that are listening are doing large scale infrastructure, all right, or large scale commercial projects. None of those sit in isolation to each other.
Yes.
And that's the real challenge is I can build the most structurally sound, resilient building, but if everything around it, Max, is, excuse my French, okay, then it doesn't make a difference about that building because it means people can't get there. They can't get out, okay? You can't operate. So what we're really saying is that the building codes are wonderful when they're in these silos, but what we're encouraging all of the, design, architecture, engineering, construction is to come into alignment around that we're looking at physical infrastructure, physical, the built environment. And if you're not thinking about building your project looks like, but you're also not taking a look at what is happening around you or not happening around you, then we think you're missing the boat. And that's what's going to actually cause insurance to keep on going up, property values to fall, mortgages, both residential and commercial, people are going to default on them. And that's the cycle that we're in right now.
Yeah, it'd be nice to break out of this cycle. Do you think we would see like a different level of code that is, from the insurance side, maybe someone could say, my building is to this level of safety. I don't feel like we're going to ever get rid of this minimum IRC, very simple code, but to have different layers that you can say is built to some standard. Do you think we are heading in that direction, or the whole code will come up?
No. I think what we're beginning to see is the reality of the balancing of there's kind of four ways that we do our risk assessments. We do what we call a risk and resilience assessment now. All right. We have 100 billion data points at the county, zip code, census tract, and parcel level. Some of the data that your folks use, CoreLogic, which is now called Cotality. I mean, we've got 100 billion, but we also have a lot of interesting ways of looking at it from a modeling and scenario setting. Talk about that, a little bit. But what our sense is that data is not the issue.
Mm.
What really is the issue is to look at forecast. So when you're building something, this goes back to, God, my father and his mechanical and his engineering way of thinking. If you're building to obsolescence, to make it obsolete,
Yeah.
right? Why build it? That's one of the problems in transportation. We build 3 more lanes on both sides of the of the highway. Boom, it's already full, right? If you're building to only hit the code, you're building automatically in our minds for something that's going to be obsolete. So we look at our data 5 to 7 years out horizon and 15, 20 years out. All
Okay.
right. And work back from that to say, this is what your future is going to look like. How are you going to build and design and architect? And then go to something that you said about insurance. I think that remember, there's different kinds of insurance. So there's insurance, Liberty, State Farm, Allstate, all of those, right?
Mm.
Then there's reinsurers. So those are the ones that back the
Cover
insurance
that.
of these companies. And they also are the reinsurers for companies and governments that self-insure. Okay.
Okay.
I'm big enough. I set a certain amount of my money off to the side to handle certain losses, but I also buy an additional reinsurance product. Okay.
Mm.
Then there's specialty insurers, Max, that are increasingly coming back to a level of that kind of fell off for a little bit. There was a lot of some of the companies that got formed are more than just shady. You got a whole set of really highly regarded, highly respected specialty insurers. And Max, what they do is they choose some form of a disaster or some type of product that they're going to, and they're not under the rules and regulations completely of the state insurance commissions,
Okay.
which means that they can price and do it. But all of them have significant data. All right. And that's kind of, we think, the incubator for the future of insurance. All right.
Hmm.
But then on top of that, you got the whole mortgage and finance industry. Right. So let me lean into something that I wanted to share with you is we met with Fitch Ratings in New York 3 years ago, spent about close to 3 hours with them. They were beginning to do a lot of outreach and internal research. All right. So Fitch Ratings. So it's Fitch, S&P, and Moody's are the big three. Fitch this past December, Max, issued a guidance, and all your folks should see it, and I'll send you the link to it. Fitch established a guidance that essentially says, if your project invests in a higher level of resilience, meaning what we're talking about here,
Yeah.
we will more than likely rate it differently, meaning better. And that rating actually starts reducing the cost of your capital. So that bond gets rated better because the use of the bond proceeds of the financing are going to be used on a project that is doing exactly what we're talking about, Max.
Yeah.
Pre-disaster, right? And that cost curve starts bringing the cost of capital down. And that is very attractive to the insurance and reinsurance as a signal. So it's just beginning to happen, but it also means that your colleagues, clients on the public sector side, and now increasingly even on the large scale private sector, need to be aware that Fitch is encouraging and incentivizing this pivot in behavior in the design and the engineering, Max, that as a result of it, we're going to give you a different rating. And as a result of that, we are going to make the cost of capital less, which is an incentive. And it is a signal for the insurers and reinsurers to look at that project and create a product that's better than the traditional one.
Okay.
Does that make sense at all?
It does. I mean, the breadth of this is kind of hard to wrap my head around. If
But,
zooming into sort of a building here, if I told a structural engineer to future-proof a building, what
yeah,
would I be asking them to do? Like, what is different in this case?
let's talk about the outside of the
Yeah.
building. Okay. Detention retention ponds, building on how much concrete and absorption of the land you're going to use. Every city, county, has some jurisdictional code or requirement that says for however much absorptive capacity that you take off of that site, you have to build detention retention. All right. We think that you should make your detention deeper, a little bit more inclusive of just the standard code, and I'll use an example in a moment. All right. But you should also make it smart. All right. You
What is
should
that?
drain the water out of the bowl
Mm.
when you get some form of an alert that you're going to have a significant rainfall. Okay. Otherwise, the bowl fills up and spills over.
Yep.
Right. We have a, a solution called the smart watershed. All right. And that smart watershed said upstream, at point, and downstream. You should be looking at all of what you've got and be able to determine how to make it, in a sense, like traffic management. You're using the flow of the water on your peak days,
Hmm.
100-year, 500-year floodplain, right? Whatever. Now, the structural engineers say to me, well, Richard, that's the hydro guys. That's somebody
That's
else,
it. I've said
right?
this.
Not at all, because that means that you then have to think about, okay, here's all of these other things that you can do, on the horizontal, all right? On the horizontal. Then when you start talking about the structural features of it, all right, so let's talk about this. Sustained wind at 130, miles per hour, all right? Sustained wind.
Mm.
Hell, I didn't realize this. It's becoming more prevalent now that hail in the United States is no longer these little pea size. The average hail in the United States is ping pong size.
What? Wow.
Yes.
Okay.
Yes. Okay. Oh, Richard, hail, it's just an automotive and, auto insurance. No, it's not. Think about the amount of wind, all right, and I'm going to talk about straight line storms that are increasing, okay? Hail hitting the outside structure, in a sense, the wall of the
Mhm.
building, okay? So we're looking now at, structural. Can the building, can some of the top floors, whatever it is, sustain a certain amount, a persistent amount of wind and a certain amount of hail, right? Because what we now know, and there's a lot of structural work that's been done, and a lot of folks are now saying, yeah, we need to spend that money because windows popping out, all right, roofs beginning to get torn apart, all right. Let's go back to that detention retention pond.
Yeah.
Okay. Howard Hughes Development Corp is, a very large residential master plan developer. They own two or three very big, sizable projects here in the Houston area. Okay. And it's not just residential, it's like residential and large scale commercial. Okay. On their largest master plan community in West Houston, they decided to kind of take on a suggestion that we made to them several years ago when we were first getting this going, Max. And they actually built their detention retention ponds anywhere from 1.5 to 1.7 larger than the code required.
Okay.
Okay. And they did it in a way where it was designed for them to be able to release some of the water and send it down. Okay.
Makes sense.
Harris County Flood Control District at the time, which is kind of the large, planner of all of this post Hurricane Harvey, upgrade and construction on it, a new flood system, heard about it, got it, looked at it. Well, guess who picked up part of the cost that Howard Hughes was going to? Why? Because it showed empirically that the reduction downstream from their development was actually going to be reduced in the sense of the flood impact.
Mhm.
So Howard, you said, listen, we're going to do this for ourselves, but by the way, there's a benefit for the larger community around me. All right. That's one thing. Okay. Second part of the infrastructure and structural part of this. All right. Um, we need buildings built that look at how they are designed to not withstand just high wind and what they now call convective. So bizarrely, we now live in a country that you can take it by the highway system. I
Mhm.
10 south. I 10 is the south. That's Hurricane Alley, hurricane on the Gulf Coast and part of the mid Atlantic.
Mhm.
Okay. Then as you come across past Texas, all right, that becomes drought and wildfires. And then hurricanes back over on the Pacific side,
Uh-huh.
right? So I-10. The I-20, I-30 corridor has been known for a small stretch of it as Tornado Alley. No, it isn't. It's wider across the country and it's broader than just I-20 and I-30. And this is where you're seeing these derechos, these straight line storms, which are essentially like a tornado on its side. Okay. More prevalent, happening more frequently. It just happened again last night.
Whoa.
Okay.
Yeah.
So you have to take a look at the country in these kind of zones, right? In Texas, we would get a massive snow and ice storm, all right, that millions of people would get knocked out for power.
Yeah.
So when you're looking at the structural engineering side of it, we believe that the structural engineers have an opportunity to look at, I'm going to design my building to this code to do this. Okay. We believe that they need to open up the aperture wider to say, we are building this building or buildings to withstand a multiple set of types of disasters. And the frequency is no longer, well, it may happen. I always hate this. They say this, 100-year rainfall.
Yeah.
Oh, well, the next one's not going to happen for 100 years. They need to just drop that. Just talk about the amount of rain that's going to occur. But so our sense is structural engineers have a significant voice and role in thinking about these buildings meeting these different levels of persistent disasters.
Okay.
Okay. And the other part of the structure is uh, so JP Morgan Chase built in Manhattan what they call the 100-year building. They want that building to be around 100 years from now. All right. And some of the structural engineering is designed that way. All right.
Okay.
It's also designed, and we're suggesting that buildings need to be built where they create uninterruptible supplies of power, energy, water, and data. If the grid goes down, is your building, is your facility, is your master plan site set up in some way to go off the grid? Because the grid isn't stable,
Grid's gone.
right?
Yeah.
No matter what we do. All right. So I may be stretching the bounds of what a structural engineer says,
We do
but
this.
we
We
believe this is
stretch our
more
own
than,
bounds, but
yeah, this is more than concrete and rebar and more than steel.
Mhm.
Am I making sense?
Yes, yeah. Are we getting changes in the environment, or is it we don't have the data? We haven't had computer systems for 100 years. Are we getting more data about what's occurring and
Yes.
population is growing? Okay.
Oh God, yeah. Yeah. Great question. Great question. Okay. So somebody said to me, well, who do we blame? I'm
Yeah.
not in the blame game. Okay. And by the way, we say this very openly. You've not heard me talk about climate change,
Yeah.
climate resilience, not because we're deniers, which we're the exact opposite. We're very open about this statement, by the way. Okay. We know something's shifting out there. All right. And I'll use an example of why we know something's shifting. But let me tell you why we know, and everybody that listens to your podcast knows. A couple of years ago, there was a tropical storm in the Gulf Coast beginning to form, beginning to start spinning. Okay. So, like Tuesday afternoon, it was a tropical storm. By Wednesday at 1 o'clock, about 24 hours later, it was a category 3 hurricane called Michael,
Whoa. That
which
feels quick.
means whatever's happening is happening. But what it means is the time that you have to prepare and get ready is now shrunk, right?
Yeah.
And the other thing is that you start taking a look at a lot of places in the country, and while they're recovering from one thing, another one occurs. So a lot of areas in this country have presidential declarations and all, right? So one on top of the other. My sense is the piece of where the weather patterns and other things are truly changing are pretty much evident to everybody. We just don't want to get into the political debate.
Yeah.
We want to basically focus on financial, economic, fiscal with an F, FISCA, and societal. That's our focus. We focus on those four: financial, economic, fiscal, and societal. And when we talk about societal, for example, we're not only talking about obviously low to moderate income citizens who are more perpetually impacted by some of these storms,
Yeah.
but we're also talking about the employees, right?
Yeah.
And are they being a part of an employer's perspective? So let's go back to that risk and insurance and finance part.
Yeah.
So over here, I've got insurance risk, all these different things. But what I also have, and this is where structural engineers really have the opportunity, it's on business continuity.
Okay.
If my operations in that building cannot be restored faster because the structural side of the building failed in any kind of way, or some form of the, horizontal structure failed, who cares? So this is the second example. All right. Hurricane Harvey comes along. You've got the major energy corridor sitting over West Houston. On the west side of Houston, that was one of the areas that got really hardest hit by the Hurricane Harvey floods. But they also had, sad but true, a massive failure of one of the largest water treatment facilities, all right, for the public water system, okay?
Yeah.
And as a result, no one could get to their offices, okay? However,
Good efficiency.
those energy companies actually got their plants and facilities on the Gulf Coast restored faster. So, Max, what happened in the energy corridor was they got their operational facilities, production facilities on the Gulf Coast restored for almost 6-7 months. The energy corridor could not be reopened because wastewater, and I'll just leave it at that, okay? 4 million gallons every 12 hours for a period of time was flooding all over the energy corridor.
Whoa.
Okay. Now, is that a structural issue? Yes. For public works, very much so. All right. But there was also some drainage and related structural parts for that energy. So you look at this as a risk, the sticks and bricks risk, but there's also operational risk. And structural engineers need to be thinking about that risk component just as much as the insurable risk. Operational risk is economics, shareholder value, revenue, right? And that's where we think structural engineers have both an opportunity and a responsibility to say to their clients, we really think you need to start considering some of this.
Yeah.
Rather than you tell us, here's the plans, just go execute the plans. We believe and are encouraging structural engineers to be our collaborative partners on not only this message, but a way to help deliver it,
Yeah.
meaning structurally, implementation wise.
Yeah. Are we currently trying to catch up to the storms that we are having. So remember, like large storms, Helene a few years ago, like
Yep.
big storms that wreck a city for some time? Or are we heading towards where it might be going, the climate, weather? If we don't know what is going to be occurring in 10 years, are
Yeah, but
we
that's the reason why I just said we are
Yeah,
very focused. So
it's hard.
pre-disaster, right? Pre-disaster risk mitigation implies exactly what you're saying. We don't care what happened yesterday.
Yeah.
That happened yesterday. What we're looking about is what's going to happen 5 to 7 years, 10, 15 years out, right? So when a structural engineer, they're not building something for tomorrow. They're typically building something for the client that they are looking at ahead,
Mhm.
right? That's the reason why we're sitting there saying is if you only know what you know today, you're going to only build to what you know today,
That's what we do.
right?
We do well.
Right? Stop it. Stop it. Stop the madness. Build to where the world is going to be. Oh,
Okay.
Richard, we don't know where the world's going to be.
Yeah.
So, in all seriousness, we know, and the data is there. We have more data than you could ever want,
Mhm.
right? But that's the other emphasis that you raise in your question is there's a lot of data. We're focused on actionable intelligence. What can the data tell us? We're very focused on actionable intelligence, Max. Okay.
If a client requests a building that is a 75, 100-year life, what
Yep.
should we be thinking about differently? How should we design this building? And how do we make these, decisions that are kind of big picture?
Depends.
Yeah,
It depends.
it
Okay.
always does.
But the variables are always pretty clear. Okay. And structural engineers know some of these, but this is where we want to partner with you and with folks that are listening in. The variables are pretty clear. Okay. One, what is the utility? What's the use of the building? What's happening inside the building?
Mhm.
Okay. Is this a commercial office building with some maybe retail, maybe even residential mix, whatever it is? Okay. Is this a manufacturing facility? Is this a hospital? You know, so the use of that asset really has a certain importance to it, number one. Number two, where is it going to be built? All right. What
Mhm.
kind of setting it? What kind of environment? What kind of location? Is this an area that's already prone to disasters? Is this an area that based on right now it's, kind of sort of bad, but increasingly it's going to get worse. Okay. So, we start looking at these variables and say, okay, if they're going to build a building that somebody really wants around for a long time, all right, you have got to look at these variables. So we've created what we call the resilience investment blueprint.
Okay.
Your structural engineers create the blueprint. All right. What we want to know is incorporating these different variables, right, and getting the right balance to it. All right. Suddenly says, well, wait a minute, Sea Line, you guys are coming in with some great information and really great forecasts 50 years from now,
Yeah.
30 years from now. Okay. But damn, that's going to cost the client 20 to 30% more. That's the reason why the other part of our work is around the whole capital investment stack to help the owner, the asset owner, the builder, the structural engineer, all to understand if you go to doing this, how can we help them offset that 20 to 30% cost?
Yeah.
Right? That's the biggest hurdle. And that's what we also want to say to your colleagues in the structural engineering world. Let's work together on getting this designed and engineered the right way to this higher value of resilience. But let us also work with you on being able to create the narrative for and with you to your clients to be able to say, here's a way to cover those costs.
Okay.
And in some conditions, not only cover the cost, but we believe there's certain things that you can do on that project to actually create more value, like certain things you can do in a microgrid or distributed energy and all these other kinds of things that actually create money for you.
Okay.
So what we're saying is engineers should never, ever going forward, based on what we've created, what we've done, including I mentioned to you about the Fitch ratings. We have a
Yeah.
way to model that. Okay. I believe structural engineers looking across the table at me going, well, that's all fine and well, but man, that's going to cost that client 20 to 30%. And I'm not
Yeah.
touching that thing.
Yeah.
But we have a way to work with them. Now, the other reality here is, Max, I can make you 100% future proofed. I
Yeah.
can. Okay. I can. $100 billion, and we're just going to build this dome over you. Nothing's going to happen. Nothing's going to happen. I'll ensure it that nothing's going to happen. It just cost you $100 billion.
Yeah.
Okay. No
It's a
one's
little
going to
shy.
do that.
Yeah.
Right. So there is, again, what we're saying is there's a certain balancing effect. And what we're saying is minimum is no longer sufficient. You got to bump this up a little bit. Okay. Not a little bit, but you got to
A
bump
lot.
this up and find that right ratio. Okay.
Yeah.
But we're not saying this. We're never going to say you need to spend $100 billion. I'm going to throw one other part, oddly, as a little deal. Where do structural engineers and elevator systems come together?
Ooh, yeah. We defer that and say the elevator supplier will tell us what the loads are, and there's so much. Everything's deferred.
But this gets to another point. Okay. Um, and it's become less than anecdotal. All right. Coming out of COVID and post COVID and with some of the tariffs, I am telling you, the elevator companies in this country and the world are stretched, obviously.
Yeah.
Okay. Because elevators, especially in high occupancy areas or whatever, are breaking down, hard to get parts, all that type of stuff. But if you look around the world, we're going more vertical now. We're going more vertical because we're in such urban concentration. Okay. I will tell you, oddly enough, I think that the world is going to start seeing in certain places, wow, we have built a lot of vertical structures. Okay.
Mhm.
This is great. Right. But the issue on some things is, can I get the product that a structural engineer is suggesting?
Yeah.
And what's my length of time? The structural engineer says, you need to design it this way. Okay, great, fantastic. Okay, now the contractor, developer, or whatever starts taking the structural engineering and go, God dang it, it's about 8 months before we can get supplied.
Mm,
That is an issue that you're aware of.
yeah.
Okay. And I am not sure what the complete answer is, but that is one of the issues that I'm hearing out across the country is we want to build it to this standard. We just want to build it anyway, but we want to build it to the standard. Richard, what are you hearing? What are you sensing about the supply chains? Okay. I think they're coming back to balance, still a little wonky.
Mhm.
Okay. And increasingly, I think that there is a lot more onshoring back to the United States for some of this manufacturing to get done. All right. But I don't want somebody to say to me as a structural engineer or a developer or a contractor, wow, this is great, but we can't get any of it. That's not true. That's not
Yeah.
true.
Yeah. I have a feeling people underestimate the longevity, the lifespan of their building. But do you think
Yes.
we would ever see a future where we have a 50-year building and a 100-year building, and this is a known, like from the insurance side, when you
Yes.
sell the product? Yeah.
Yeah.
Do you think
I
we're
mean,
heading that way?
JP Morgan Chase's headquarters in
Yeah.
Manhattan is considered
Yep.
to be that kind of representative type of thing, right? So to some degree, yes, you're going to see 50-plus-year buildings in America. It depends on what the developer or the owner is willing to invest.
Yeah.
That's the issue, right? And if they do some of the things that we're talking about, what's their risk tolerance, right? I want to do, Richard, 1, 3, 5, 7, and 9. 2, 4, 6, 8. Screw it. We're not doing it. Why? We'll we'll pass that risk.
Yeah.
This will absorb because you're helping us find out how to finance it, how to offset it. Okay.
Yeah.
That's the message I think that, you sit there and think about is, will buildings be built to last 50 years longer? I think you're beginning to see certain asset owners lean that way because partly legacy, right?
Mhm.
Brand legacy, but partly because they're sitting there kind of going, I don't want to be back at this 25 years from now. If I'm building it for a longer, longevity, it means at least 25 years from now, yeah, I may have to replace a few things, but I'm not having a whole, CIP, a capital investment plan that just, I'm just constantly spending money
Yeah.
to fix it. I'm beginning to say I spent the money up front one more time, and I'm now kind of lowering not my completely my maintenance. Oh, but Matt, do you remember the building in Florida that collapsed at Surfside?
Yep.
Okay.
Yeah.
Structural engineering problem.
Yeah.
No, it wasn't.
Well, yeah, exactly the main.
No,
Yeah.
it was not a structural engineering problem. It was that building had a requirement and they were collecting from the residents every month, every year, a certain amount of money, and they chose to defer their maintenance. Chose to
Yeah.
defer maintenance. Building collapse. Oh, God, what happened? The swimming pool, the parking garage, this thing. We had signs. It's a structural engineer. That. No, it wasn't. The homeowners chose to defer their maintenance.
Yeah.
Within 24 hours, Miami-Dade County and others went and found over 200 buildings in greater Miami-Dade that also were deferring maintenance.
Oh
So what
gosh.
happened? What happened? They sent out communications, as did the engineers and as did the insurance companies, that essentially said, we just want to let you know, you're deferring your maintenance. And by the way, that puts you out of code. But the insurance company said, you know what? You can defer the maintenance all you want. Defer it. Next year, your insurance is going to go up 50%, right?
Yeah.
Risk to reward, incentivize or penalty.
Yep.
Okay. But the reality is structural engineers,
Well, we
those
did. I
structural
know.
engineers came in and, well, I can send the best structural engineer. His name is Moses, Muhammad, and Jesus show up in a building,
Yes.
okay, and tell you got a structural engineering issue, okay? And here's the report. Somebody's going to have to make that decision on deferred maintenance. And
Mhm.
by the way, that's a bigger issue in this country than most people realize.
Yeah.
I will tell you it's coming to an end because the economics of deferred maintenance. But this is again where I think structural engineers have an opportunity. And let me just be blunt about it. They have an opportunity. We think they kind of have an obligation, but
Yep.
it's also, frankly, a revenue scenario. And that is that, look, your deferred maintenance, you can defer it, but let us make sure here's your insurance guy, here's the building code. We're coming to you saying, do the right thing. Let's get going.
Yeah.
Spend some of the money now. Because when you don't spend the money, it's going to cost you more and or you're going to get sued.
We'd like to avoid that.
We need to be very open about this narrative where structural engineers, yeah, there's bad actors all the time. There's always bad apples and no matter what.
Yeah.
We are universally saying that structural engineer world knows this, gets it, knows we think they need to open the aperture up a lot more to include some of the things that we're talking about, and we'd love to work with them as we are with some already. All right. But what we're also saying is we believe structural engineers are part of the leaning into what we're talking about, into future proofing. All right. And we believe point blank that there is a business, a revenue opportunity.
Yeah.
because no one's going to do this. Hey, Richard, you and Max, we love listening in on this. It really makes us feel really good. Okay. But
It'll cost money and
I got to pay people, right? And that's where I think we need to find and establish how we work with you and your colleagues who are listening on finding a couple of pilot projects.
Ooh.
That's what we're doing right now.
Okay.
And it's not putting our toe in the water. It's really showing how these projects can be done and scaled so that people get confidence, Max, in doing this, moving this pivot along.
Perfect. I want to put a lot of show notes in the box down there so people can go and dive in a little bit more because there's just so much here. But in a sort of a closing sense, if we were sitting here 20 years from now, future-proof America, ROAR has exceeded, what will be fundamentally different about how we design buildings in America and built environment in general?
Right. I saw that question and I have pondered that question.
Yeah.
Now, 20 years from now, what I am hoping this will have done is it will have completed the pivot from one, throwing the responsibility to somebody else. Asset owners, developers, building owners, investors, whatever, the whole set of stakeholders. We believe that this idea that it's somebody else's responsibility or I'll throw it to somebody else.
Mhm.
I think that is irresponsible. But 20 years from now, I think what we would like to see is buildings in this country, around the world, retrofitted, upgraded where it can, and new construction to be at a standard, this called future-proofing standard, that says 20 years from now, we've had these persistent and increasing amount of disasters. We can't change that. All right. These increasing amount of disasters. And as a result, people, employers, and communities are thriving, not just surviving from the next apocalyptic type of thing. But do I want to live 20 years in that kind of world? Hell no. But, 20 years from now, I owe it to my son and his generation and your generation, Max, to inherit a world that's a lot better than I have. So each successive generation is supposed to. And I don't mean to preach, but when you're a structural engineer, you've got a sense, an ethic, okay, that says, I want to leave the world better for the next generation. And my job as a structural engineer is to find that path to that. So 20 years from now, I'd like to see individuals, families, small businesses, employers, and communities that are thriving because they've been designed and constructed and they're operating at this standard, knowing that there are certain things that even if we started doing certain parts that the climate change world wants us to, it's not going to happen overnight. We're still going to go through a phase. Okay.
Yeah.
And that's what our objective, Max, is to hand the world off to your generation that we can just keep on looking on television or the screens and kind of go, that is the coolest thing in the world. But I do not want to live in that world. Okay. So that's where I think we have a responsibility.
Yeah.
20 years from now.
Oh my gosh. Thank you so much for talking to me.
And Max, let me know what we can do to help. We just want to be able to find a number of projects to work on with your listeners and start moving the proof points forward with all, the insurance and the finance and the state and local and all that type of stuff in a way that people can look at and kind of go, I can do that. Let's start scaling this across more projects.
Yeah.
All right.
Well, thank you again.
Thank you, Max, for all that you guys do. Talk with you soon.
Thank you.
Cheers. Thanks.